First off, I guess I should say electricity, especially when you get into 110, is fatal. Don't play around with it if you don't know what you're doing. There's plenty of people out there that can give you guidance. Biggest trick is don't touch two wires at once. It's pretty simple, but if you don't have things grounded correctly, you never know where that current's going. So don't play with your life. Alright, with that said, this is what I am currently using for my lathe power. I have the, see if you can see it, a DC treadmill motor down here. And this power supply, it's kind of dirty if you hook it up just the way I hooked it up. I actually have it hooked up to where I'm just using the control panel from the treadmill, and go through the, I'll show you what this does. So besides the fact that you got to go through and push stop every time and reset it and get this to get where it'll actually let you start it again, because let's say I'm running, forgot my spindle's not hooked up, so I'm obviously running. I don't know what that clunk was when this started. Oh yeah, I do it. But what happens is this has like a dirty power to it, and it'll go through highs and lows. It'll run at a constant speed for 1 minute, and then it'll kick down. Part of that may have to do with the fact that this is a treadmill board, and it's got all these, this is one circuit board, it's got all these little safety features knitted into it to where, you know, you get your safety switch, and then you have your your proximity sensor, constantly measuring the speed. Now I have no proximity sensor hooked up to this, and that might be why I'm kicking through highs and lows. There's actually a video on the internet where the guy shows you how to modify this board. You pretty much take the board off, you flip it over, you scratch out a whole bunch of this shit, you just scratch the back of the board so the contacts separate, because all you're really using on this board is like right in through here. This is a 12 volt and a 5 volt, or a 9 volt and a 5 volt, and those are used for running your monitor. And if you were to modify this board, I think you can get a lot cleaner power out of it. But I haven't modified any of these boards yet. So if you're using this current setup, you might want to check out that video, and perhaps you can make this board work a little bit better if your lathe is doing the same thing my lathe is doing. I'll make another video about how to wire that into your reverse switch, because I'm pretty good at electrical stuff. My dad's a master electrician, and I've been a mechanic all my life, but this thing is a freaking nightmare. It doesn't make any sense. But so the first board I showed you is one type of circuit board you'll find in a treadmill. The other type is this, which is actually an older style board. You can probably pick these up off the internet for a lot cheaper. I get all my treadmill stuff pretty much for free. Anytime I see somebody throwing one out, I say, hey, do you want that? Or I think I paid $10 for one, and it was probably the second one I got because the first one didn't have the motor I was looking for on it. But another thing you want to check is when you get your treadmill, a lot of them aren't real used, so you can spin the motor freely, but if they're used a lot, it'll give you a lot of catches on the backspin, and that's not a real big deal because most of these are clockwise rotation, which pretty much fit into any lathe in the back, down in the bottom, as long as you don't move where they're at or try to run a jack shaft and run this in reverse. But yeah, these things are run so much in one rotation, and the brushes in these, at least in these type, are straight. So technically this could be a multi-directional motor, other than once you run a motor for blank amount of hours, play an algebra equation, you kind of make the brushes conform to that direction. So when you run it backwards, that's why if you notice, you can't feel it in this one obviously, but if you have one of these and you run it backwards, you'll feel like little hitches. It feels almost like a servo motor. And what that is your brushes have conformed to running one way, and when you run it backwards, they get caught on the little lines on the copper, and you can feel it. It makes it feel like a servo. You can actually see where it stops pretty much the same spot every time when I turn it backwards, where when I run it forward, it just, it's random because that's how it's been run for so long. So it doesn't really matter because you're not going to be running your lathe a whole lot in reverse. Keep that in mind. If you are planning on running a lot in reverse, find either one of these that are labeled, or I should say not labeled, as a single direction, or one that runs relatively smoothly. This one's actually pretty smooth compared to the one that's on there. So along with that circuit board, like I said, I get all my stuff for free. So yeah, this is the easiest one to work with. You don't have to do any modifications to the board. This is the one that's kind of a pain in the butt because to get the best performance out of it, I believe you have to do some scratching off. Along with this one, there is usually another one. I think that one is off of an old enough treadmill that it only had that board because it was just ran with a potentiometer. I have no idea. Yes, I do. Sorry, my shop is a mess. My brain is about the same. And somewhere in my electronic stash here, I threw that other board. Is this the one? No, that's... Anyway, the other board's obsolete. We'll just say that. It's the one. It'll have another... it'll look like the two boards combined for the most part. It'll have a little... whatever you call it, transducer, transistor. That's the newer style board too. So I don't have a clue what I did with that other one. I'll remember as soon as this video is over. I'll be like, oh, it's right there under my feet. Which actually, speaking of, it might have been. Okay, well, I'm clueless. So anyway, with this older style board, get you a nice good close up. God damn, I hate this chair. Got a little divot in my cement floor, like rolling backwards on me. I'm just going to go through a general how to hook this up to run this motor with the best performance. I wish I had somebody to hold this damn camera. As most of you know that's had one of these treadmill motors or have watched any videos on it, they always have 4 wires coming out, the red and the black, and then they got 2 blue ones. The 2 blue ones are to a temperature sensor, another one of those sensors that actually clicks in right here, and you can actually just grab those 2 blue ones and pull that whole sensor right out the back. Get rid of those wires, absolutely pointless. Just makes troubleshooting everything a lot harder. You don't need them hooked up even if you do get this going. So start with the power cord. We got our white, our green, and our black. God, I'm getting so frustrated. Okay, so we got our white, our green, and our black. Obviously, black is load on 110. White is your neutral. Green is your ground. Your green, you'd be smart when you hook up your thing to hook your green to your machine frame. Your white and your black. White and your black. I hooked it into the 15 amp circuit. Most house circuits are only 20 amps. You're best off having some kind of fuse circuit in there. It's better to switch the breaker or the fuse. And this is actually a little breaker. But it's better to blow this out or flip it off than it is to burn out your motor, because then you're stuck with a hell of a lot more work than just flipping this back on. And if this keeps flipping, obviously you're going to know there's some kind of electrical issue. So if you look at these boards, they're labeled. And you probably can't see that, but anyway, I'm going to tell you what it says. This one says motor, black, A-, red, A+, These are the two coming out to the motor where you'll wire your switch in here so you can change directions. It's these two. You don't want to wire it in here because it'll be switching the electrical polarity going into the board, and the board's not designed to be running off a reverse polarity. So once these two come out, then you'll wire in your switch over here, and then it'll continue on to your motor. The choke goes to this fella right here, whatever comes with the treadmill. Most of them have this. The newer boards, I believe, don't have this, and that could be why I'm getting dirty power too. And then you have your pretty much your AC in. So we have AC hot and AC neutral. So my AC hot, which as you can tell, I wired my load, goes over to my on and off switch. This is kind of a fancy one. It was about 14 bucks a day, so you can probably find them cheaper somewhere else, but I kind of liked this model, so this is what I'm going with. And I believe this is a DC switch. I found it in the automotive section. You can do a simple toggle switch and stuff, but the idea is I'm going to remove that emergency stop button so I can just pull that on, and if there's an emergency, I can shut down my lathe instead of trying to flip a switch. Or so you'll take your blue, and that'll be wired right here where it says blue. Now originally this had the two boards, and this is how I disconnected everything, and this is how it'll be wired without that other board. Before, I don't remember, I think this blue was wired into the other board, and then another jumper came over and came into here, and yeah, it was just retarded. So my blue goes there, which is my hot, because my black turns into my white, which turns into my blue. The wire color's non-specific at this part. These are specific. This is all just wiring I added from off the treadmill. So yeah, these wires mean nothing. This is what matters. And then my white goes to the neutral. And this is actually kind of dummified. It says, got a little bit of a glare. It says blue and white. Easy enough. And then this, grounded. Now, moving along, we will take our, I'm terrible with technical names, call it a transducer, trans modifier, trans amplifier, trans something. Anyway, this turns AC to DC power. How it works is there's a bunch of, you can obviously see the little coils. There's even more little coils inside, and AC comes in and it creates an electromagnetic field, which the other wires that are wrapped around pick up that electromagnetic field, and then they send it out into a different kind of current, so it changes your AC to your DC. This is necessary. I actually labeled these before I pulled them off, as they're labeled here. You got the, and then where's that light coming from? You got the, anyway, you'll see it when you get there. There's an LG1 and an LG4. I labeled these. I don't know for a fact. I don't think it matters which one these are connected to, as long as this is connected where it's supposed to be, because, well, it does the same thing either way. But I labeled them just for lack of complication. So LG3, LG4, with that hooked up, we move on. So black and red, pretty simplified. These are the two you switch around when you want to change the direction of the motor. If you have a reversal switch, I forget the name of that switch, but if you have one of those switches, or a three-way switch or whatever for reversing a DC or AC motor, that's actually for an AC motor, and that's probably why it's such a pain in the butt to wire in, because it had, well, it was a nightmare. But yeah, if you have one of those, you'll wire it in between here and here. So this one, again, it's labeled, and you have the LG6, LG5, or you have black A minus, red A plus. So I'm not going to clamp these down all the way, because I'm probably going to switch them here in a moment just to show you exactly how this works. if you are a novice or whatever. So plug those in there, and that is it. Oh wait, no, my bad. Okay, on the other side of this board, we have this little 3-prong plug. This one also went over to the other board, and the other board is a pulse width modulator. It sends out an electrical impulse to control the speed of the motor. So as denying that, you have getting rid of it, you have a red, black, and white out of here. And you simply, this only plugs in one way. Now this red, black, and white, it actually turns into, since I use different wires, I have a gray, white, and a red white. But this is how you would wire a potentiometer. You have red, black, and white. If your potentiometer is facing you just like this, so you can read the numbers if there are numbers, and your connections are down, you would do black, which is kind of confusing because since this black is a load, this black is actually a ground. The white on this one is called a wiper, and the red on this one is your high. And this is kind of weird because on here it's actually called low, wiper, high. But in reality, ground, we'll call it, these two don't really matter. I guess we'll just say that. And I'm bending everything out of shape, or it was bent out of shape. These two don't really matter. If you get these two switched around, what's going to happen is this is going to run in reverse. So instead of it turning from left to right across the top, it'll turn from right to left. So if you have that, you can just switch these two wires and make it work correctly. Or you can have it switched around and have it work the other way. So black, white, red when it's facing you, black, white, red. That's all there is to that. So with all that wired in, let me plug this in. And these are the dangerous wires. These ones, you might get a little spark off of them, but they're not going to kill you. These ones can kill you. So I'll give myself some juice. Oh, damn chair's rolling again. And, well, nothing happened. And like I said, those ones can kill you. Those ones can kill you. So, I pull this. I get a light on. Where'd the light go? Okay. So there's the light. I had a hard time seeing it through this little camera lens. And then with that going, this potentiometer, these things actually, I'd suggest, this is a 5K. You can run a 10K, but it seemed like when I put the 10K on here, it got very fast, very quickly, and this one gives me a little bit more control. You might even try a 1K or a 2K if you don't like the control you have off of a 5K, if you want it to where you can dial it in pretty correctly. Or you can buy what's called a 10-turn potentiometer, and you want a wire wound potentiometer. I don't think this one is, but they last the longest. But a 10-turn, you have to turn this little knob 10 times before you reach full potential. So if you really want speed control off of one of these motors, say you're just running this motor and a single drive, 10-turn would be awesome. I'm going to be running this motor, and I'll have 6 different gear ratios on this motor. So a 1-turn works fine because I'm going to have, you know, whatever on the first gear ratio, and then the next gear ratio is going to be probably mid-range to a little bit higher of my first gear ratio, and so on. So these don't kick in until you hit about 2,000 to 3,000 K on a 10-turn. A 5-turn, they probably kick in about 15,000 K. So you'll have a little bit of turn before it does anything. And there you go. And the motor's running. And then you just give it a little more crank. And with this setup, this motor runs smooth. The other motor, I had it all bench set like this, and you can actually hear it go high and low and high and low. And I figured once I put it on there, the drag of all those rotating pulleys and my lathe spindle would work to steady it out, and it did a little bit, but it still goes through phases. So yeah, all you do is and that's max speed at the moment. There's also this little switch right here. There's some of these have different little trim pots, and if you're not familiar with them or you don't know what they are, I wouldn't play around with them too much. This one is obvious. It says max speed, and this is actually bottomed out, so when I turn this, and that's maxed out. So that's my max speed on this motor, which is actually quite fast. It's probably running 4,000 plus RPMs right there. But my point is, with this, you know, if you're designing your own setup, or you're putting one of these motors on with a single pulley, your best bet is to figure out a pulley ratio, figure out your max speed. I have a little handheld tachometer. It only costs about 20 bucks. It seems to be relatively accurate for what I'm doing. At least it gives me a rough idea of what things are spinning at. So, you know, the best bet is to figure out what your motor runs at, and then design your pulley setup around that so you can get a good gear ratio. And I would say, you know, you don't want to max this out because you're going to be harder on the electronics, but if you can do this halfway and then design your pulley setup to where you're running in the range of this halfway on your lathe that you want to be, you'll be doing pretty good. Keep in mind, the faster this motor spins compared to the speed of your spindle or your chuck. Say this is spinning at 1,000 RPMs and your chuck is spinning at 100 RPMs, you're going to have a lot more torque than if this is spinning at 100 and if your chuck is spinning at 100. When these are going slow speed, especially since this is a brushed motor, they lose a lot of torque. If you have a brushless DC motor, they're a lot higher in torque. So keep that in mind and try to set it up to where you're getting, you know, get this 1/3 of its speed before where your spindle's running at its slowest speed that you want it, say 100 RPMs. You know, have this one going 300. And that way, if you have to make a heavy cut at slow speed, hopefully you'll have the torque there that you need to get through that cut without everything dogging down on you. Because if you have this set low, and this is only spinning 100 and that's spinning 100, you know, as soon as you start cutting on that, and even little cuts, it'll bog this down. And it might make it through the cut, but you want to make it through the cut easily, not with pressure. So yeah, that's this circuit. That other circuit, I'm going to do some experimenting with that down the road, and I'll probably post a video. And when I take this out and put that back in, I'll show you, I'll make a video on wiring up that forward reverse switch. So a lot of you won't have the headache of that. And yeah, hopefully that simplified everything enough to where nobody has to ask any questions. If you enjoyed this video, make sure you subscribe to my channel. I think I've only got 1 subscriber. I haven't been on there in a few days, but start showing some interest and I'll start posting some more videos. I apologize for the first couple videos on there. There's a lot of talking, a lot of theory, but it's supposed to be to make people think, not necessarily to show a dummy how to do it. You know, make them think about it, and they'll be able to solve a lot more problems down the road as opposed to giving them the answer. So if you don't like those videos, tough shit. Hopefully they make you think. Yeah, I'm gonna go enjoy my cookies and get my ass to some of these projects I have to do.